Welcome back to day 2. So you've probably heard these 3 phrases thrown around like they all mean the same thing. Artificial intelligence, machine learning, deep learning. People sprinkle them into sentences almost at random, and it makes the whole field feel way more confusing than it needs to be. Here's the good news. These 3 are not competitors, and they're not random buzzwords. They actually fit neatly inside each other, like Russian nesting dolls. And once you see how, a huge amount of the confusion just melts away. Plus, today we're going to watch a machine actually learn, live, with real code. Let's untangle it. Let me give you the whole map up front, then we'll zoom into each piece. Picture 3 circles, one inside the other. The biggest, outer circle is artificial intelligence, the entire field. Inside that sits a smaller circle called machine learning. And inside that sits an even smaller circle called deep learning. So deep learning is a type of machine learning, and machine learning is a type of AI. They're nested. Every deep learning system is machine learning, and every machine learning system is AI. But not the other way around. Keep that picture in your head, and the rest is easy. Here's the shorthand. AI contains machine learning, which contains deep learning. The outer circle, AI, is just the goal. Get machines to do things that normally need human thinking. It says nothing about how. The inner circles are specific recipes for actually pulling that off. So when someone says AI, they're naming the dream. When they say machine learning or deep learning, they're naming the method. Same family, different levels of zoom. So let's talk about the circle that changed everything. Machine learning. For decades, if you wanted a computer to do something, a human had to write out every single rule by hand. If this, then that. Spelled out, step by step. Machine learning flips that completely. Instead of writing the rules, you show the machine a pile of examples, and it figures out the pattern on its own. It learns from the data. That one shift, from telling to showing, is the heart of modern AI. And the best way to feel it is to watch it happen. So let's do that. Here's the plan. We're going to take one simple job, spotting spam text messages, and solve it 2 different ways. First, the old way, where we write the rules ourselves, by hand. Then the machine learning way, where we just show a model some labeled examples and let it learn the pattern itself. Then we'll run both on brand new messages they've never seen, side by side, and watch what happens. This is real, working code. Same idea you'd use in an actual spam filter, just shrunk down so we can see every piece. Let's build it. First, the rules way, which feels the most natural. We make a list of suspicious words, things like free, win, prize, claim. Then we write a simple function. If the message contains any of those words, call it spam. Otherwise, call it normal. That's it. We, the humans, decided every part of this logic. It's clear, it's readable, and for about 5 minutes, it feels pretty clever. But keep an eye on that word, free, because it's about to cause us some trouble. Now the machine learning way. Notice something huge. Nowhere in here do we write any rules about spam. We never mention free, or win, or anything. Instead, we turn our example messages into numbers. Then we hand those examples and their labels to a model and call one magic line, model.fit. That's where the learning happens. The model studies the examples and works out its own pattern for what spam looks like. We're not programming the answer. We're letting it learn the answer. Same job as before, completely different philosophy. Let's run it and put them head to head on 3 brand new messages. Look closely at this. The second message, win big, claim your free gift, both approaches correctly call it spam. Great. But look at the other 2. Are you free this weekend? And feel free to reschedule a call. The rules approach flags both as spam because it sees that word free and panics. But these are totally normal, friendly messages. The machine learning model? It gets them right. Normal. It learned that free isn't always spammy, from context. Nobody told it that. It figured it out. And that right there is the whole lesson in one picture. Our handwritten rules were rigid. They saw one trigger word and got it wrong, twice. The machine learning model looked at the bigger pattern across many examples and made smarter calls. We didn't make it smarter by writing more rules. We made it smarter by giving it more and better examples. That is the superpower of machine learning, and it's exactly why it took over. So why does this matter so much? Because the real world is gloriously messy. For most useful problems, recognizing faces, understanding speech, detecting fraud, there are simply too many rules, too many exceptions, for any human to ever write them all down. Machine learning sidesteps that. You give it examples, it adapts. When the world changes, you feed it fresh examples, and it improves. No rewriting required. And it routinely picks up on subtle patterns that no human would ever think to code. That flexibility is why machine learning quietly runs so much of your digital life. Okay, so that's the middle circle, machine learning. Now let's step into the smallest, most powerful circle of all, deep learning. Deep learning is just a particular kind of machine learning, one that uses something called a neural network. Picture lots of simple little units, arranged in layers, passing signals forward from one layer to the next. When you stack many of these layers, hence the word deep, the network can learn staggeringly complex patterns. It's loosely inspired by how neurons connect in the brain, though it's really just a lot of math layered up high. Here's what makes deep learning such a big deal. With older machine learning, humans often had to handpick which features of the data mattered. Deep learning skips that. Feed it raw stuff, pixels, sound waves, words, and it figures out the useful features all by itself, layer by layer. That ability, combined with mountains of data and serious computing power, is exactly what unlocked the AI boom you're living through right now. The large language models behind ChatGPT and Claude, deep learning. The tools that generate images and understand your voice, deep learning. It's the engine under the hood. Now, deep learning is powerful, but it is not always the right tool. If you've got a tidy spreadsheet of numbers and not a ton of data, classic machine learning, like the little model we just built, is often faster, cheaper, and easier to understand. Deep learning really earns its keep when the data is huge and messy. Think millions of images, hours of audio, or oceans of text. It's hungry. It needs lots of data and lots of computing muscle. So why bother keeping these three straight? Because it makes you much harder to fool. When a product slaps AI on the label, you'll know that's just the outer circle, the goal, and you can ask the real question. How does it actually work, and where's the data coming from? You'll be able to tell the genuinely impressive stuff from the marketing fluff and the realistic from the science fiction. Understanding this little nest of circles turns you from someone the hype happens to into someone who actually gets what's going on. So let's lock it in. Artificial intelligence is the what, the goal of machines doing thinking-style tasks. Machine learning is a how, learning patterns from examples instead of being handed rules. And deep learning is a more powerful how, stacking many layers to crack the really hard stuff. Three circles, nested neatly inside each other. Goal on the outside, methods within. That's the whole map. And there it is. AI, machine learning, and deep learning. No longer a jumble of buzzwords, but a clean little set of nesting dolls. And you even watched a real model learn something we never explicitly taught it. Tomorrow, we're going to zoom right into that learning step itself and see, in plain English, how a machine actually pulls a pattern out of a pile of examples in the first place. It's the beating heart of this whole field. Thanks for building with me today. See you tomorrow on AI in 5.